Hi and hello, I am Athena Pondian here. In this video, we are going to discuss about one of the most important biomedical domain, which is very important for those who are willing to go for the research or go for the higher studies. This particular biomedical domains are very important. If you choose these particular biomedical domains, then only according to that only you can able to choose your research area or choose your post-graduation study, all this thing. So everyone should know about this particular various biomedical domains. In other words, we can able to say various biomedical areas that is coming under the biomedical, all the things we are going to discuss in this video. Come, let me start the video, various biomedical domains. Biomedical engineering is just like a ocean. If you want to study about that particular biomedical engineering, you should aware about all the areas in the biomedical. In that, the most notable biomedical domains we are going to discuss in this video. The first thing is biomechanics. Of course, biomechanics is nothing but the study of structure, function, and motion of the mechanical aspects of the biological systems at any level, from whole organisms to the organ cells and cell organelles, using the method of mechanics. Of course, we need to apply the basic mechanics to each and every organ of the human body. What is the need of studying that particular mechanics is, if you want to replace any of the human organ, especially in the orthopedics, that is in the bone replacement, you should aware about the basic mechanics of that particular bone. Then only we can able to replace that particular bone into the artificial bone. For that purpose and other purpose, for example, if you want to study about the artificial heart, for example, if you want to study about the prosthetic heart valves and everything, you should aware about the natural mechanics of each and every tissues and each and every organs of the human body. Then only you can able to acquire knowledge and replace that particular natural devices or natural organs into the artificial organ. So that is what this particular area is about. That is called as the biomechanics. Then the next important topic, that is a domain area, is bioelectronics. This bioelectronics is the application of the principle of electronics to biology and medicine. That is, it says about we need to apply some of the electronics concepts to determine the parameters of the human body. That is called as the bioelectronics actually. For example, we can able to say this bioelectronics application is in artificial limbs, humanoids, the various sensors that are attached to the human body are the most important notable applications coming under this particular bioelectronics. Then the next important area, that is a domain area, is a biotransport. Actually, this is a movement and the transportation of the substances and molecules within the body. Especially, there is an exchange which happens within the cell as a material, food, water, or heat is channelized and transported across the biological membranes. That is a nano level study. If you want to, of course, we are all know that is a transportation occur in the human cell. That is called as an active transport and a passive transport. Through that particular transport, there are so many things happen. The exchange of gas, exchange of nutrients has happened. Some of the release of unwanted things has happened. All the things happen because of this particular transportation. So if you want to study about that particular nano level study of the cells, that biotransport area is very important. And then the biomaterials. Of course, there are three different biomaterials. Most important biomaterials are there: metallic, polymers, and ceramics. Of course, this particular thing is very useful for make any of the artificial organ, because these are all the biomaterials are very biocompatible. It should not be give any ill effect to the nearby organs. That is why this particular biomaterials are very useful for making any of the artificial organ to replace, especially in a dental. We can able to replace the natural tooth by using the ceramic implant. It should not be give any of the ill effects to your root canal, any of the ill effects to some of the tissues and cells in the mouth. So like that, all the other organs, natural organs, if you want to replace it, for making the artificial organ, this biomaterials is very useful to make it. We can able to say some of the examples. It includes, of course, I already told you, metal, ceramics, glass, and polymers. These materials can found in this thing such as a contact lens we can able to make using a biomaterials, pacemakers, heart valves, orthopedic devices, and some of the more number of artificial organs we can able to create using this particular biomaterials. And bio-photonics. This particular bio-photonics is actually denotes a combination of biology and photonics, with photonics being the science and the technology of generation, manipulation, and detection of photons, quantums, units of light. Photonics is related to electronics and photons. That is, if you want to study about this particular photons, electrons in a human atom, that's actually human organ is also considered as some of the atoms and the movement of the electrons and everything is happen. If you want to study about that particular photon level study, this particular biophotonics area is very comfortable. Using that, we can able to frame some of the imaging techniques. Using that, we can able to diagnose some of the illness through the imaging of the biophotonics. All this thing happen under this particular biophotonics area. And medical instrumentation. Of course, we nowadays instrumentation play a main vital role in the healthcare devices. There are over 15,000 biomedical equipments out there. All the things are coming under this particular medical instrumentation. The equipments can be divided as a major, minor, and the critical. All these electronic equipment is coming under this medical instrumentation area. You should know about the basic electronics, basic electrical and electronics to frame any of the devices. And if you want to troubleshooting that particular equipment, you should aware about this instrumentation concept. And then we go for the radiation physics. This particular radiations comes in different forms of energy. Of course, in the hospital, 50 to 60% of the equipments are coming under this particular radiological equipment. That particular, all radiological equipments are emitting some of the radiations. Most importantly, all that particular radiations are not giving any ill effect to the users and also the patients. Most importantly, you need to exactly note about the exposure range of that particular radiation. Then only it should not be giving any secondary effects to the users and also the patients. So if you want to know about that particular thing, how much amount of radiations we need to give, how much amount of radiation should not be give, all these things, if you want to note, you should aware about the basic physics of that particular radiation. How far this particular radiation have giving ill effect to the patient, like that you should know about it. If you want to study about all these kind of radiations exposure from the equipment, this particular area is very comfortable for you. And then medical informatics. It is actually an intersection of the information science, computer science, and healthcare. This will deals with the resource, devices, and methods required to optimize the acquisition, storage, retrieval, and use of the information in health and biomedicine. That is actually in the medicine, there are so many informations we need to aware about it. All these things, documentation work, all these things are coming under this particular medical informatics area. And then medical imaging. Of course, especially in the multi-speciality hospital, whatever the hospital it may be, the doctor want to diagnose any of the illness of the internal organ of the human body. This imaging play a main vital role. There are so many imaging equipments are there, especially in particular, we can able to note that X-ray, CT, MRI, ultrasound, endoscopy, using the catheter, we can able to view some of the imaging. All the things we can able to take using this particular imaging techniques, because each and every equipment, for example, X-ray play a important role. We can able to view the two-dimensional view of the organ, and in the using the CT, we can able to get the three-dimensional view of the patient organ. And MRI, it should not be acquire any of the radiation exposure to the patient. And ultrasound, we can able to without any radiations and without any sound effect, using the sound, we can able to get the particular imaging. All these techniques are very comfortable for the doctors to determine what has happened in the human body. And the hospital management. If you want to work as a biomedical engineer in a hospital, you should have aware about this particular hospital management, how we can able to manage the work under the pressure, and what are all the things required. What are the things required under your control, and how we can able to make a documentation of each and every equipment, how we can able to make a billing of each and every equipment, all the things, the profit and the loss of all these revenues can be generated only if you are aware about this particular hospital management. Of course, it is a term very broad in scope and may be defined from different aspects. It mainly relates to management of all aspects of the hospital, a coordination of all elements of element. Each and every element, you should have some of the records. Okay, that is coming under this hospital management area. And then biomedical signals. Most of the parameters, especially we can able to call electrocardiography, electroencephalography, electromyography. There are so many signals. Using the signals, we can able to identify, we can able to predict what is the condition of the patients. If you want to study about all these signals are coming under this biomedical signals. You are aware about the digital signal processing, how we can able to acquire that, using the electronics, how we can able to acquire, to amplify it, how we can able to study about each and every signals that is gathering over from the human body. All these things coming under this biomedical signals area. And biosensors. In the previously, we have studied about the biosignals and everything. If you want to acquire the biosignals, or if you want to acquire any of the parameters from the human body, this biosensors play a main vital role to acquire what is happening in the human body to the externally. It is pointed out using this biosensor. Okay, that is what a biosensor is. An analytical device used for the detection of chemical substances that combines in a biological component with a physiochemical detector. The readers are usually customs designed and manufactured to suit the different working principle of biosensors. Okay, that is what in all the technology, most probably we can able to take a wearable technology. Using the wearable technology, we can able to acquire so many parameters diagnosis. So that are all the things happen only because of this particular biosensors. And medical robotics, it is a leading technology actually. A medical robot is a robot used in the medical sciences. It includes surgical robots. They are used in most of the telemanipulators, which is used for the surgeons, activators on one side to control the effector on the other side. The doctors give the instruction to the particular robot. The robot can able to do what are all the instructions collected from the owner. That is what most of the surgeries also happen in most of the multi-specialty hospitals in Southern Asia. So this is the area coming under the medical robotics. And then artificial organ. Whatever that we are studied coming under the biomaterials, biomechanics, all the things are studied because of making artificial organ. All the organ, most of the 75 to 85% of our human organ can be replaced by using the artificial organ. So these are all the topics coming under artificial organ. If you want to replace, especially it comprises complex medical devices that have active mechanics or biomechanical functions such as heart, lung, kidney, liver, pancreas, or neuro sensory organ. All the things can be replaced by using some of the biomaterials and using some of the concept of the biomechanics. We can able to replace the natural organ by the artificial organ. If you want to make or study of artificial organ, this particular area is very comfortable for you. Then the biostatistics, actually, it is a statistical process and the method applied to the collection, analysis, and interpretation of the biological data, and especially data relating the human biology, health, and medicine. This is particularly for the biomedical engineer and hospital. We taken over the hospital administration. This particular biostatistics is very important. At the same time, in the company, the senior level managers, sales managers, service managers, and the production managers, all these people should aware about this biostatistics. Okay. So that's all about the notable areas under the biomedical. This is the most important area actually. There are so many other areas are also there. These are all the things very, very important. If the person is going to do some of the research, or if the person is going to do some of the higher studies, these are all the notable domains and the leading notable domains I mentioned over. So thanks a lot for the patience. And in the next video, we are coming with next information about the biomedical devices. Thank you very much.